Hello everybody and welcome back. This is Michael, KE4EST. And I've got this Heathkit IM-28 restored. And we're going to go over what I did to restore it. And then I'm going to put the case back on it and let it warm up for a couple hours. And then we'll go through the alignment procedure. As you can see here, first off, I don't know how good it's showing up in the camera. Okay, one of the first things I did here was, like I said, I don't know how it's going up in the camera, but these knobs were pretty dirty, especially on the, just slowly, easily take one off here. Especially on around the edges here, people grab, their fingers, you might have grease, oil, and just generally, your fingers, have that oil on them and dirt, and over time this was all, you can see it's a lot shinier now. They was pretty dirty. I put those, dropped them in the ultrasonic cleaner. So I did with those. And this, the face of it here there was some couple of pencil marks. It was kind of hard to see, but when you're in person with it, you can see things a lot better. I cleaned all that off, cleaned it up really good. The face of the meter itself had over here some pretty good scuff marks right here where somebody had, when moving it around or just setting it in storage or something had scuffed up against it. And I took that stuff like I showed you in the first video and went over it real careful. And all that buffed out really nice. It looks almost new. You can see there's a crack right here. You can see that in the camera. That was already there, but that ain't really going to bother me any, especially something I want to put on the bench and use as a daily driver. I ain't worried about it. It's not going to be a shelf queen, but I did all that and cleaned it all up. I still keep seeing little pieces of dust here and there. That I ain't going to worry about probably in another week or so when I'm using it, but once in a while I might wipe it down. But when you're doing a video, you're like, oh, look, there's another piece of dust somebody's going to see. But anyway, so I cleaned all that up. And of course I went through on the other side and all these potentiometers and wafer switches and cleaned the contacts up with them with cleaner. That's pretty much that on there. Let's turn it around. And let's see. Put a new fresh battery in it. Cleaned all this in here. Good, all this, so this make contact good. But when I first put the battery in, I took a regular handheld tester I use for just doing general tests and wasn't getting a voltage across here. I was like, okay. So I went back over, took the battery back out, went and took a rough little file and kind of very carefully hit the inside of that spring. Make better contact. And let's see, while we're on this side here, I checked the tubes. The 12AX7 was, or 12AU7, let's get AU7 in it, right? 12AU7 was good and good enough for this. It'd probably go for several more years maybe. But in this type of circuit where you can adjust it, we got the zeroing where you can, over time, as it gets a little weaker, you can adjust it and bring it back. But since I'm using it for a daily driver, I went through some 12AU7s and found one that read really good and high and matched. And it's got 2 triodes in it, and the better you can get these to match, the better. This one on my tester, of course, it's all, whatever you want, how you want to look at it. It's all relative, really, with all these different tube testers. But I think this one reads 94, or is it 95, 95, something like that. And the other one was reading in like the 70s, upper 70s, but which is good. But I went ahead and just replaced it. Okay, as far as that, and then over here, let's bring in the Zoom in a little bit here and see if we can. Okay, replace this 1600 volt capacitor here. I didn't have one of these, so I got this one from DigiKey. Put a little sheathing over it here, which would have been fine, but you know, no big deal. And then put that over there just to help a little bit, make it look a little neater. I was going to try to come up with a different way to mount it besides this, like the old one, but that was pretty much the best way to put it in there and keep the leads as short as possible and all that. So replace that one. Let's see, get this oriented so you can, well, that reflection's making a weird light in it. You can see up in there, replace this capacitor here. Now this one here and this one over here was 0.05 originally. They don't really make those anymore. A lot of manufacturers go with the 0.047 or 0.47. You know, you don't see as many 50 microfarads anymore. It's 47 microfarads, things like that. So I replaced this with the Illinois capacitor, and I went with the 0.047, and they're rated 630 volts. So they're really good to go there. You can see the other one here. This just right here. You can see it right back in there. This one, I was going to, because one side's going just to ground, and then this up here. So I could have brought maybe a ground out from up here somewhere and flipped it around the other way, but it wasn't that bad. You can push this stuff around, these wires around, and then I kind of tied these wires up some. Remember, these all sprawled out, but I just push it around, get in there, get your soldering iron in there very carefully. I took my needle nose and tweezers and all that and worked my way back in there, and just went ahead and changed it out without having to tear much stuff out. Went through the resistors. They all tested really good, so I was happy about that. Didn't have to change any resistors out in this one. These two capacitors are fine, so I left those. And then you can see, let's bring it this way maybe, this capacitor here, the electrolytic, change that out with another Illinois capacitor, 500 volt, 22 microfarad. And the diode I did change out, like I was talking about. Went with the 1N4007, put that in there. And one other thing, this indicator light, it was a neon lamp, and I was looking at the schematic, and let's just grab that real quick if I can get this to focus in here. You look at the schematic, and right here shows your heater windings coming off of here, your heater winding going to your 1287, 6A05, and then it shows 6.3 volt lamp just coming right off of there. So when after I shot the initial video and I was studying the schematic and everything, and then I was like, oh wait a minute, maybe that's not, you know, a neon lamp, even though it sure did look like one. Maybe it's just some kind of solder type, you know, just somebody just soldered in, you know, in there or whatever. So I was like, okay. Then I got to looking at it, and yeah, it was neon. Somebody had some light back in there. You can zoom back in a little bit here. Somebody had went different from it. I don't know if it was originally or at some point, but they went different from the schematic and put a neon in there and had wires going back and coming off the mains to feed that. And I didn't even see a series drop-in resistor, so which was kind of odd, but it was working, I guess. Maybe it wasn't working, so I don't know. But anyway, I pulled that out of there. And what I did was went with, let me see, I've got a bunch of these LEDs here. You can see they're got a flat top to them. really good. I call plasma LEDs, but I think it's just some kind of name or something. No plasma in there. But, I was looking at the pack from DigiKey that I got, I don't know, sometime back a year or so or whatever. I ordered a bunch of them, and I really like these. I've used these in several other things. So I was thinking about those. I was thinking about that, how I was going to do that, and I got thinking about these LEDs here, and I was like, I think I'll use those. Maybe that'll look good. So I set up on this little circuit board and tested out I run 6.3 volts AC, and now what I've done, this yellow wire here goes back to one side of where the heater is on the 6.3 volts, because if you look here, get this here, if you look here, we've got the 6.3, one side's tied to ground, so that yellow wire comes over here and ties to this side here on the top side. Okay, and then it goes to the anode of the LED. Trying to get that where you can see that good. Kind of hard to. It goes to the anode of the LED, and then it come out, goes, LED, and comes, and it goes. I got it stuck in that holder, and it comes off the cathode side and goes to the anode side of a diode. Now this diode's a 1N 4007. Don't have to be, 001, 404, whatever, work just fine for this low voltage. But I just happen to have I got tons of the 001s, but I had the 407s out, so I just grabbed 2 of them. So I mean, this don't have to be that, but it's what I use, and it goes through that. And then I've got I was looking through my Allen Bradley style resistors that I've got that's new old stock, and I found a 1.6K that was close enough to about what I wanted to use, so I put that in there just keep it period, to match the rest of the got this line cord in the way, don't we? Match the other resistors in the build. So I used that one there. It could have been, could have used, one of these or something like that. But anyway, and that goes back to ground, this resistor. So this resistor's tied to ground because the other side of over here is tied to ground through the resistor, through the diode, through the LED, and then this goes back to one side of the winding on 6.3 volts. So that's what I did there. So that should work out good. This wire here I was talking about that was kind of taut and whatever, I just left it in there because I got thinking, well, that's going off the battery. The here it's not going to bother anything. I'm going to have the case on it. It ain't like I'm going to be looking at this all the time, or I'm going to be doing something all day in here every day to get in my way. So keep that as short as possible. Maybe that's what they were doing, but I just left it that way. That's fine. I think that pretty much covers everything I did there. Like I said, went in and cleaned everything, washed all these potentiometers in here out for the alignment adjustments and these, and cleaned all the contacts. The line cord looked like it was in really good shape. The only thing I did on it was the prongs where it plugs into the wall. Those I cleaned up. They were really kind of corroded and didn't make real good contact. So now, well, let's see. I guess we can just leave it like this here. Let's bring the light away just a little bit. And I'm going to plug this in, put it on the variac, and we're going to bring it up. Now just remember, when you do anything like this, and you got it open like this, there's high voltages in here. This one here is pretty much 120 or 125 volts or less. That transformer is pretty much just an isolation transformer, 1-to-1 transformer, but still you don't want to get zapped. So Be careful where you put your fingers. Keep your fingers out of it. I'm going to flip it on. And let's see. Let's bring it on the front. Okay. Now I'm going to reach over here and slowly bring up the variac. There's about 40 volts. Everything's looking good. Alright, we'll bring it on up about 60 volts. Starting to see, you probably can maybe see it from here. That's starting to light up there, even at 60 volts, pretty bright. Okay. The tubes, it's really hard to tell, they're trying. Okay, let's bring it on up. Alright. There's 120 volts right there. The tubes are lighting up good. Indicator light. Nothing's going crazy in there. So I'm going to very carefully watch where I put my fingers and turn this around. Okay. And we can already see that it's going to need some adjustments here. This here's pegged out over here. So let's just do an initial test and see if the zero adjustment's going to work. Yep, there we go. See if we can bring that around. But you can put that on 0 and then let it keep warming up. And then 30 minutes, this will be moved up to here. Let me zoom in on that a little bit. It might be up there a little bit, or it may be down there a little bit. You know, so like right now I've pretty much got it on 0. Okay, so what I'm going to do now is put the case back on it, put the screws in it, because there's no internal adjustments. You know, I'll double check that I'm getting, you know, the batteries getting contact good and all that, but put the case back on it, because there's nothing, you know, inside needs to be adjusted. And let this warm up pretty good. And once this gets warmed up really good, about 2 or 3 hours, like I say, I'll probably let it run a few hours. Kind of watch it too, you know. When you restore something like this, initially, okay, everything's going great. I don't see smoke or no fireworks or nothing like that. I wouldn't want to leave this on and walk off and leave and go to town for a while or go to bed or whatever. I would shut it all back off, unplug it if you're going to have to leave or go to bed or whatever. But make sure you're around to kind of watch it for the first, you know, little while, first day or two, to make sure everything's going to be fine with it. Because usually like these, I'll leave them on all the time, 24/7. But in the first couple of days, it's a good idea just to, you know, double check, because it could be a resistor that showed good. Now it's, once we got some voltage applied to it and everything's working, it's going to start breaking down and causing something to pull too much current somewhere. So anyway, let this thing warm up and we'll be back and we'll go through the alignment procedure. Okay everybody, now we're back. I've let this warm up for a couple hours. Actually, it's been more like 3 hours. And I've purposely bumped this off here. I've played with this because as it warms up and nothing's calibrated properly, if you got this set wrong, you can see this will peg out over here. And I really don't like it being shoved over here to one side, so I would bump it away from it. Okay. But the first thing we're going to talk about here is, before you do all this, it says right here in the alignment procedure, turn the instrument off and make sure it's unplugged from the AC line. Okay. Make sure, you know, it's in the off position over here. Because what that does is that shorts out this meter. The terminals behind it get shorted out. Okay. And then it says take a plastic screwdriver, and put in here and adjust this, which I've already done this with it. You see I've got it on right now, but with it off, you adjust this very carefully right here in the front till you get this resting right at 0 and you're looking at it straight on. Get down, look at it straight on, and make sure that's right at 0. Then you can take it and plug it up, and if you have issues with it being up here, something are weird, like you look at it and it's like, this thing is up here. Take you a dryer sheet, like a bounce dryer sheet or something, run over the face of it, because this will build up static sometimes. Just discharge any of that static, and make sure it comes back down over here somewhere on the left hand side. Then adjust that, because you don't want to adjust this with the, got a charge on it, it'll be fighting it. So get that where you want it, right on the 0, adjusted. Then you can plug it in, turn it on, let it warm up 2 or 3 hours, whatever. Okay, so let's start the procedure from there. Okay, I'm going to read it over here to the side. I've got the printed out the testing calibration for this particular model. We're going to do it a little bit different than what it says, because there's one part where it's talking about using the battery and putting the battery back in, and then taking the probe and actually sticking it inside, you know, where the AC line comes in and all that. But there's no need in doing that, and I like it being put together so that it, you know, with the case on it and it warmed up, it's gonna stay, you know, lined up better. And with modern stuff these days, I've got a power supply over here I can set for exactly 1.5 volts. Check it with another meter, make sure it's exactly 1.5 volts when we get to a place in that, and set all that. So it says here, check operation of the 0 adjustment control. Turning this control should move the meter pointer part way up the scale. Set the pointer to 0 at the left side of the scale and check for 0 resting when the function switch is changed to DC minus. It should be possible to obtain a 0 adjustment control position that will prevent the meter pointer to remain stationary when switching from DC positive to DC negative. If there is an appreciable 0 shift of more than 2 divisions on the scale, it should be regarded merely as an indication that the additional aging of the 12AU7 tube is required. Because that's another thing too, if you build one of these from, you know, brand new, which is rare to find anymore, and that tube's never been plugged in at all, never been used, you got to age the tube a little bit, and that's what they're talking about there. It says this aging can be obtained by leaving the instrument turned on for a period of 48 hours or more, or through continued use of the VTM with periodic calibration. And also, after you do all that, also I'm going to add to that and say, you know, you get one of these and it just cannot, you can't get this to happen, then you need to, you know, check the circuitry around your 12AU7 tube or replace your 12AU7 tube. I'd replace the tube first and go from there. What they're saying then is you take this 0 adjustment, and in case anybody's wondering, yeah, I've got knobs without the pointer on them that match this brown style from the 70s of this case style. I just don't have them on there yet. I've still got to dig them up and put them on here, but maybe at the end I'll show a picture or something of it with them on there before I upload the video. But what they're saying is your 0 adjustment. Let me just zoom in on this. Okay, bring that where you can see the meter good. You may not be able to see my hand, but I'm on the 0 adjust. Well, I mean, you can see my hand, but and what they're saying is you can see that needle moving. Okay, so bring that down all the way to 0, and it may not exactly look like it in the camera angle, but you need to look at it straight on and get that right on 0 as best you can. And then they're saying when you go to DC minus, DC negative, if you look real close, you can see that moving just a hair. And that's okay there, but if you set and mess with it just a little bit, barely bump this now. But you remember, this here is a, you know, multi-turn potentiometer here, okay? So you've got, you know, you can just barely move it, it'll help. If it was just a 1-to-1, it'd be harder to get this to do that. But now when you flip it back and forth, you can just barely see a little wiggle in there. And you can set and play with this. So like right there, now you don't see any movement when you switch from, I know you can't see that, but when I'm going right here from positive DC to negative DC, that needle is not doing any movement. Okay. Alright, then it says insert the test lead plug, which I already have. Now this is not an original test lead. This is one that a guy sells. He's got a little website and he's got an eBay. If you go to eBay and look up test leads for Heathkit and put this model in, or he sells several of them. He makes these, or you can get them as a kit where he just supplies everything and you put it together yourself. So you got one probe for AC and doing your ohms readings, another probe for DC, and then the ground. But that's what I'm going to be using, because this didn't come with the original probe. So I've got test leads from him before and they've always worked out good, so I just went with it. Or you can always make your own, you know, and still make them just as pretty. I just opted to be lazy and just, he's already got them ready to go and just order them. Okay. Alright, set the function switch to DC plus, which we do. The range switch should be to 1.5 volts. So put that down over there. Connect the probe and the common test leads to the flashlight battery and adjust the DC calibration control so that the meter point falls directly over the small red dot on the meter face. Approach the red dots going up the scale by turning the screwdriver control and watching the meter read 1.4 volts and 1.5 volts and then the red dot. As soon as the red dot is reached, stop turning the DC calibration control. Remember that the range switch must be set on 1.5 volts for this adjustment. So we're not going to do that. We are going to hook this up over here to a power supply. So what I'm going to do is hook it up to this power supply I've got over here. Back that off. If the meter does that, better back it off in a hurry. Okay. Just going to hook it up. So obviously we're at the 5 volt scale here and we're reading 2.3 volts. So it's obviously needs to be calibrated. So since it jumped way up there, let's bring this DC calibration control. So what I'm going for here. Take a non-metallic screwdriver or something. I don't want to hurt that in there, break anything. And we're going to bring it down here, maybe a little past 1.5 there. Okay. Now, I'm not going to go to the red dot. There's no need in going to the red dot. And when you use the red dot with the battery, you're close, but you're not exactly on it, because most batteries, the reason that red dot's past there, most fresh batteries are 1.6 volts. On these 1.5 volt batteries. But if you hook it up, if your battery's 1.55 or maybe it's 1.5 and you're up there, then you're going to have your calibration off. So with the good power supply, I'm going to adjust that. I'll move my hand just a second on me. So they're at 1.5 volts. And when I move this switch up, it should, into 5 volts, 1.5 volts should read right here at 15. Now it may be off just a little bit. It's not going to be perfect with these meters, and it's a hair off. What you can do too is calibrate these things to say, or use a different voltage, 5 volts or whatever. If you're going to be using the 5 volt scale a whole lot with whatever you're testing you're doing, calibrate on the 5 volt scale. If you're going to be doing a lot of testing with, say, 12 volts or 13.8 volts and things like that with ham radio or whatever, go up here to the 15 volt scale and calibrate your scale with this on the 15 volt scale. So that's reading, yeah, that's right at 1.5 volts right there. It's in here between the, that's 1 volt and 1.1, or 1. 2468. So 2, 4. Well, now it moved just a hair down, but you can. That's another trick it doesn't tell you. You know, if you're going to be doing this a lot, in this, or the 50 volt scale, whatever, you're going to be working a lot with that or something, or the 150 volt scale. Get you a good known power supply and get that, calibrate that scale, and that'll help you out a lot there. Okay, so I'm going to leave it calibrated on the 5 volt scale. Okay, I mean, that does that. And when we disconnect it, it should fall back to 0. Okay, and then if it, well, let's see, yeah, you'll have to, the initial time getting everything set up, and you'll kind of get used to it. Sometimes you have to bump this every so often. That's why they brought it out front. If it was something that you could set and forget one time, kind of like these, it wouldn't be, but they brought it out because you're going to be fiddling with that. And for other things too. Okay, next it says we're going to do the Ohms check. It says turn off the VTVM. Install the battery by starting the top plus end into the battery cup, and then blah blah blah. It's just telling you to install the battery. I've got the battery already installed. As you see, we didn't use any of that when you used the battery, so we can skip that. Turn on the VTM. And of course now we'd have to let it warm up again if we was going to do all that. So I'm just going to, we're skipping all that. But it says put it on the ohm scale. Okay. And as you can see, I've not done any pre-alignment on this after I went through and cleaned everything. Of course, I'm cleaning these pots in here and I'm working them back and forth. Nothing's been pre-aligned up. Turn the VTVM on and set the function switch to ohms and the range switch to R times 1K. Okay. R times 1K. Set the ohms adjustment control for full scale or infinity. And that would be, some of them's got, the little sideways 8 symbol for infinity symbol at the end of them. This one actually says I and F for infinity. So you grab this here, the ohms adjust, and it should come right up there. If not, something else, maybe you need to check your potentiometer. But we should be able to bring that right up to and lay it right on infinity. Okay. Set the probe switch to AC ohms. If you got the original probe, it'll have a switch on it. The original probe will have a, it's fatter than this one here, and it's got a switch on it. And all the switch does is put a 1 meg resistor in line for DC, or takes it out of the line for, AC and ohms. But you flip your switch if you got the original one. But so it says set the probe switch to AC ohms and touch the probe to the common test clip. The meter pointer should drop to 0 at the left end of the scale, no resistance. So what they're saying is, now if I touch these two together here, it should come back down to 0, and it does. Then you go and it goes back to there. And that's all they go over on that. So here's something else you probably notice. Let's see if it does it on this one. Let's come all the way down. Let's touch them together. Yeah. You see how it's reading a little bit high from 0? It goes back to infinity. And that's another thing too. Each time you change it, sometimes you have to bump this a little bit. That's why these controls, of course, are brought out front. Bump that right on infinity. Okay. Now you see that and you're like, oh, something's wrong with it. No, what it's doing is reading this resistance in these leads. Because we're reading right now like 0.3 ohms. And that's about typical, when you got lead resistance. But what you can do to know that out is put your test leads together. Take your 0, bring it down to 0. Okay, and then take them loose, of course, and then grab your ohms adjustment Bring that up back up to infinity. Now this should go back to 0. Now what you've done is nulled out the resistance in these wires. So if you're doing some really low ohms measurements, you know, something on the first scale, then especially something way down here, these meters are pretty accurate. And I'll just show you. That's fine. Let's see how accurate this sucker is. This is a 10K resistor. So 10K, so let's go up here to the 1 times K. So it should put us at 10 times 1,000. Adjust my infinity. Okay. And we'll just touch it together. Oh, huh. I forgot to zero this back out. Okay, make sure you bring your 0 back. If you change it to higher scale, go back to shorten it out and put it back on 0. And now this one's off. Okay. Now if I test that resistor, look at that. 10, right on 10. 10 times 1,000, 10K. Okay, now, and that does that. But don't leave it on this, because your needle, you know, you got your battery in circuit now. It's going to start draining your battery. It still takes a long time to drain it down. With this, the current's so low, but I always put mine back to DC. When it's just sitting on the bench, you know, idling away. Okay, AC calibrate. Okay, now it goes over what to do if you got the 3-line cord or 2-line cord. Now some people, it depends on what you got, so you'll need to go over the different ones. Mine's a 3-line cord. It says remove this from remove the probe. Set the range switch to 1.5 volts and the function switch to AC. So put this back down here. Put this on AC. You set pegged out. Okay, adjust the AC balance control so that no movement is detected when switching from AC through DC negative and DC positive. So it's AC balance control down here. You want to adjust that. And it's a little more touchy because it's 1-to-1. And it come up a little bit. So I'll bring this back down. Okay, so I need to bring this one up. Just to here. This is a little touchy. There we go. Okay. But once you get it set, it should be good for a while. Okay, set the range switch to the 150 volt range if you wired your VTVM for 120 volts AC operation, or the 500 volt range if it's wired for 240 volt operation. So we want to come up here to 100 times 150. Set the function to AC, which we're already on. Set switch on the test probe to AC. If you've got the regular test probe come with it, put it on AC. Reinsert just put it back in there. Okay. Like that. And then it says connect the test probe to the side of the AC line with the highest reading. Adjust the AC calibration control until the meter pointer indicates the line voltage. Okay, so I've got this one set. So we should only need, since it's grounded, we should only need this one. We shouldn't need both. Okay, I plugged it in the AC side there. Be very careful doing this. And I've got it plugged into a Variac that I've got set with another meter to read 120 volts. Our line voltage here is about 122.3 to whatever. It kind of fluctuates, but anyway, go into the AC calibration here. Now we're at the 150 volt scale, which is, we want to 0 to 15, but now it's at a 0. So it's 10, 20, 30 up to 150. So set this out AC calibration control until we read 120 volts, or wherever your line voltage is. And it's a little touchy as the other one. And there you go. Your AC side's set. Again, if you work with low voltage AC stuff, you know, whatever, it's nothing wrong with taking it and putting it on your AC low voltage supply that goes up to 12 volts or whatever, 10 volts, bringing this down here and adjusting that to get it to read exactly right. Okay, and then put that back there. DC, I use it most on DC anyway. I hardly ever use AC on the bench. As far as line voltage tests and stuff like that, high voltage AC, you can put this on AC and bring your, put this over on AC, bring your, this here, that's pretty close. I mean, you can use it for, you know, AC meter's good for decibels and stuff. That would be, you know, your low ranges. And the biggest part about having one of these on the bench, instead of having, say, a digital meter, if you're trying to adjust something like an IF can or whatever it says, put a meter on it and adjust it for 1.6 volts or whatever it says. You know, I'm just grabbing a number out of my head. You know, when you're adjusting that and you're watching a regular meter with numbers and the numbers are just jumbling around, and you can do it, but it's a pain in the butt. You watch that needle, you know, let's just pretend we got it hooked up. I'm trying to adjust for a peak. You can watch that needle and say, I want to peak out right there, and I'm like, whoop, and then past it, go back up, past it, right, past it. There's the peak. Now I found the peak. Very quick and way better than doing the a digital meter. So, and this is great to have too, for it's hard to hurt these things when you're working on, you know, tube type equipment and stuff. You got the range set wrong or something, you come across a high voltage, it's harder to, you might sometimes, you know, if you're way down here, don't using common sense, and you're trying to test 1,000 volts or whatever, you can warp that needle over there and hurt this. But I'm talking about the circuitry inside. It's kind of hard to, you know, they're pretty unforgiving, or they're pretty forgiving, but they're pretty forgiving, and so it's just so much nicer to watch that. And like I said, this is going to be a permanent thing on the workbench. So, but anyway, there you have it. This video was kind of long, but you know, I think it needed to be to really go over everything and talk about everything and all that. So I hope you enjoyed it. Stay tuned. Another week or so, I'll come up with another project. I've got several things in mind. See which one I tackle next, and we'll tackle it, and we'll get it on here, and we'll go over it, whether it be restoring a piece of equipment or a radio, or just talking about maybe something, you know, else. May talk about programming Arduino or something next, who knows, but I've got several things in mind. But anyway, until next time, this is Michael, K4EST 73.